So in the scary chapter on math, it starts out, it talks about random. We've already used random. It talks about noise. But noise generates a more controllable range of values. So in the example that I have here, it's going to plot a red dot using noise, and it will plot a green dot using random. It's still putting both of them, what is essentially in a range based on the height of our sketch. And so when I run it, it looks like this. Comes out. So as you follow the red dots, it's doing a dot, and then it's moving over one pixel, it's doing another dot, moving over a pixel, doing another dot, moving over another pixel, doing another dot. And that's really clear when you watch the red ones, but when you watch the, oh, well, they used to be green, but the green on the white background didn't show, so I changed it back to black. So I forgot to change the comment there. But as you look at the black dots, it's plotting one black dot for every red dot. But you can tell that on the random ones, it's pretty random. What's nice about Perlin noise is you get a random sequence, but the variability from number to number, it could go up, could go down, but it's not going to be a dramatic change up and down. Where you see random, it could be up at the top and up at the bottom, up at the top, up at the bottom, which it often is, and then in the middle, and then who knows where. So when you want to just cover your whole screen with a bunch of random dots, well, random is going to work really well. If you want to have your random numbers vary, but in a more controllable pattern, noise works better. And the way that we keep getting a different value out of noise is we just plug into it an ever-increasing number. So we say, give me the noise of, and it starts out at 0. And then we add to it 0.01. And then we add 0.01 to 0.01, and then it becomes 0.03, 0.04. And it just keeps going. And as we feed in those different numbers, it gives us this pseudo-random pattern, where random is just giving us, it looks like dots everywhere. So random can be useful, but if you want things to be more related to each other, you generate a range of values using noise. So that's all I have to say on that. The next issue is to look at the planets. Now if I run the sketch here, we'll see that I have a planet orbiting a sun, and there's a moon orbiting that planet. Ooh. Disadvantage of how this is set up is it's not class-based, so if I add more planets, my code just starts getting really long and ugly. And what we're going to work on this afternoon towards the homework is using a planet class, and even then a moon class, and thinking about how can we work with those together. So that's what we will be putting forth on this. But the two things that are at work here are we are using rotate, we are using three things, and we are entering the matrix. So this isn't Wachowski brothers film where we enter in the matrix. Coen brothers doing matrix. Now that would be an interesting thing. That would be a whole lot of interest. But with the matrix, what we do is the matrix is where you say store whatever the current transformation information is of my sketch. So store where's my origin point and where is my rotation at, or what is my rotation at, and any other transformations that are applied. So store that, so then when I make changes, I can go back to that previous setting. So when I say push matrix, it says, okay, I want you to remember what we currently are. And then when you say pop matrix, it returns us back to that setting. Because it's possible to push multiple matrices. So you push a matrix, you do some changes, then you push another matrix, do some changes, pop that one, do some more stuff, and then pop the original. Now you're back to square one. And a really good way of practicing this and getting to understand it is to actually create a solar system, which is what we're going to be working on this week. And there are examples in your book, and we'll be working with some examples in class here. I'm going to just do some indentation changes here to try to just make things a little bit easier to see what is happening. So we can see when I push matrix, then I translate, draw my sun, then I'm going to rotate everything so that the Earth is going to keep rotating around, and I draw my Earth. Then I'm going to push that matrix so that I can translate for the moon and rotate the moon, draw the moon, pop the moon's matrix, and then pop the other matrix so we're back to ground zero. Otherwise, if you don't ever pop after you push a matrix, if you just keep pushing, pretty soon you get a rotation and a rotation and a rotation, and it gets really messy. Because if you don't pop it, it doesn't undo. So it remembers where things are. Now if I don't translate, and we'll take a look at what translate does here. If I don't translate, we'll see that currently my moon drew my sun drew itself at 0, 0. So when I painted the sun, I said I want to do it at 0, 0. By saying translate, I translated to the middle of the screen, and that sets that origin point. So it sets that origin point. It sets the origin point away from 0, 0 and moved it to the middle of the screen, so it drew the sun here. So what translate does is you can now take, where's my origin, where's my registration point that I want to draw something from. So if you think back to the very first homeworks that you worked on, where you're like, I want to draw a circle here on the screen, so it might be 123 and 98. And then I want to draw this rectangle kind of in relation to it, but that means my x would be 121, my y, okay, the thing's this tall. And you had to do all this, stupid math and figure it out. Translate allows you just to say, move this and then draw my object based on a 0, 0 coordinate. And you say, I want to draw my object here. I want to draw my object here. I want to draw my object here. And the drawing of the objects is, we can use numbers to draw the objects, but when we start doing rotations, objects rotate around that point. So if we don't translate over, the rotation happens from the top left corner of our screen, so we can see that that's not working terribly well for this, because my planets are now rotating around this top corner. See? Whoop, there. Oh, they're gone again. And that's not really useful. So when I use translate, I'm able to say I want my planets to be rotating around this point right here in the middle. So that's what translate did. Now if I didn't want it to be the middle and put in some other number, I could say something like, oh, I don't know, 200, 300, and that becomes the point. So 200 over, 300 down, that's the point that everything is now centering on. That's my new 0. So translate creates a new 0 point, and you're saying where you want that 0 to be. And then rotate will rotate around that origin point. So usually, if you are going to use rotate, you have to use translate unless you want everything rotating around the top left corner of your screen. So if you don't use translate, rotate won't work. That's important. We have to do that. Now you will notice that the moon is rotating backwards, and the moon is rotating around the Earth. When we open Flash and we get to a screen and it says, hey, I'm making a new file, you'll see that there's a bunch of different formats that we can choose from on the list. The one that we want to choose is ActionScript 3. That's the format that we're going to work with right now. The next thing that's useful when we're doing this, if we're trying to create sprites to use in our project, typically the artwork isn't going to be terribly big. If the artwork's not going to be big, I recommend you make the height and width of your document the size the maximum size you want your image sprite to be. In this case, because we're doing artwork that will kind of be for planets, whether you make them round or not, or even look like a planet, I don't really care, but I'm going to encourage you to choose a square dimension. So you choose something that is square. In this case, because we're going to fit a bunch of these on screen, not just one, we're going to choose something along the lines of, say, 50 by 50 pixels in size. And then we can say, okay, if you know what color you're going to be putting your project on, it's fine that you can choose a color right now. You know, if I'm doing my planets in space, I would probably want a black background. So it's nice to draw my artwork on the colored background that I want. The background's not part of the artwork, it just gives you a visual reference. So that's why it's just nice. Choose it now and then you're good. Now I can hit OK, and we're now ready to go. Across the bottom of my screen I see frames. Each of these little rectangles signifies one frame of my animation. An animation is simply a series of images that play quickly in front of your eyes, one image to the next, and due to persistence of vision it causes the illusion of continuous motion. That's all animation is. So to create an animated sprite, we're going to make a series of frames. These frames will have differences between them as they differ from frame to frame to frame. When we hit play, we get to watch the magic happen, and it's really cool. One other thing to be aware of on this is Flash is animating at a default of 24 frames per second. Processing is attempting to animate at a default of approximately 60 frames per second. So you can build your animation, you can bring it into processing, and it looks like it cranked down 2 Red Bulls before you hit go. That can be problematic depending on what the artwork or animation is, and you may need to adjust accordingly. We can change the frame rate in either of those, either in code or in Flash, and animate to kind of a common standard. Or set, so we can tell processing I want you to run at 24 frames per second, or we can tell Flash I want to animate at 60 frames per second. But right now, we're just going to make some different frames in our animation. Now we have a variety of drawing tools in your toolbar on the right-hand side of the screen. I like to draw with my brush tool because it works really well when I'm using my tablet. Now if I'm going to make another planet, this time I'm going to make a planet and I will use a blue color. Now as I look here, I can see that, well, that's really small to try and draw, and it's hard to kind of, you know, stay in the lines when. So what I like to do is zoom in a little bit. Command plus and minus allows you to zoom in and out when you're working in the tool, so I can zoom in and see what's going on. So now as I go to draw, if I want to draw my next planet, I'm going to make a blue planet here. Now if I've created the first frame of my animation, now my planet's actually going to be a big blue eyeball, and it's going to be blinking at us. Because it can. It doesn't have to be, oh, it looks like a rock floating up in space. Boring. Let's add a little bit of fun to it. So if I know that this is going to be my eyeball, and I'm going to draw that. Now if I move to the next frame and want to start doing the next frame of my animation, I can do that. If I click here, nothing happens. What I have to do is I have to insert an empty keyframe so that I have something to work with. And to do that, I can right click, I can use pull down menus, or there's an F key in the keyboard I can use, and I use F7. So I clicked my mouse in frame 2. I find F7 on the keyboard, I press that, it inserts an empty frame, and then I can now draw. Now you may notice there's a little problem if I can't see what it looked like before. That makes it a little bit tricky. Fortunately, Flash has some animation tools, of which one of those is called onion skinning. Onion skinning allows you to see your previous frame. Down way at the bottom, next to your kind of playback controls, there's a little button that you can click on called onion skin. If you don't know what the little icons are doing at the bottom, you put your mouse over one, you wait for the tooltip comes up and tells you what it is, and you say, onion skin, you're my bud. Let's go for it. So I click on onion skin, and it gives you a ghost representation of what the previous frame looked like. And now what I can do is I can redraw my object. And I'm going to fill in with paint as I add more frames to my animation. In the beginning, I'm just going to create kind of the outlines. I find it's easier to draw my outlines, frame, 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 and then go back and add in my color and paint it in, where then I will add in other features into this eyeball. Now, if I don't want to use F7 because I refuse to remember keyboard shortcuts, if I right-click in the next frame, I will see Insert Blank Keyframe is right there. I can choose that. I get my next blank keyframe, and now I can draw the next frame of my eye. And I can also now go under Insert Timeline and choose blank keyframe as well. 3 ways to do the same thing. F7, insert timeline, blank keyframe, or right-click, insert blank keyframe. All of those are completely valid ways of getting to the same destination. And now, after I have a few frames of animation, I can grab the red handle up in the timeline. That's my playback head. And I can scrub, sliding back and forth across the timeline, and see my animation start to unfold. Go, okay, I kind of like that. Okay, so the eyes open, goes down and closes. Now, if I want to repeat a frame and not redraw it, I can hit F6, and that would repeat a frame. Or I could now insert another blank keyframe and just draw it closed. If you want to slow down your animation, if you find it goes too fast, the way you slow it down is you add more frames to it. More frames equals more time. That's how animation works. So if you make change happen quickly from frame to frame, it's going to be very fast, because animation is change over time. And time is represented by numbers of frames. Each one of these boxes is a frame. So if we want to control our animation, we slow it down by adding in more frames into the mix. Now, one thing you'll find is when you're doing animation, there is a sense that periodically you feel like you are doing the same thing over and over and over, because that is kind of part of it, as you are redrawing. The good part is when you're doing it on a computer is we have options within our tools as you gain experience to work smarter instead of harder, so you can do it more efficiently. If I turn off onion skinning, if I turn on looping, which is right next to onion skinning, then I can hit the play button at the bottom, and I can watch my eye continually blinking. I don't think I like that. I'm probably going to modify it so it stays open for a while and then it goes down and blinks. Or it kind of looks like it's jumping rope or something. I'm not really sure. So if I want to extend a frame or add frames to an existing frame, I can do that by right-clicking and choosing Add Frame. So insert frame somewhere. Insert frame. F5 on the keyboard will also do it. Otherwise, under Insert Timeline Frame, can do that. Now if I watch my project play, we can see by having a bunch of frames where it's now the same thing over and over, it appears to pause at that moment. One thing we can do to slow it down, as I mentioned to one person, is I click on a frame and I hit F5. That now extends the exposure for that frame. I move to the next frame, F5. Next frame, F5. Next frame, F5. And what I'm effectively doing is slowing it down by making each frame stay on screen for 2 frames instead of 1. Now if I watch my movie and hit play, we will see it plays at a much less painful speed. It's easiest to draw everything on single frames because you can quickly navigate between those drawings, and then you tweak your timing. Trying to color this in, I could just paint in more colors. We do have a paint bucket. One word about the paint bucket is the paint bucket requires us to have an erase paint bucket. There we go. It requires a continual area to fill. So if I click with the paint bucket, if I choose a new color, choose a bright color, if I click out here, it's like, well, I don't know, what is the shape you are trying to fill? If I click in here, can't do that. If I click here, it can do that because that shape is a contained path. If it's not a contained path, it has a hard time figuring out where should it stop filling. So if you draw something, then you try and use the paint bucket to fill and it doesn't work, it means you don't have a closed path that you're trying to fill. I need a brighter color than that. Oh, that might work. No. That'll work. All right. Now, you can navigate back and forth through frames in your animation simply by, wrong color, by using comma and period on the keyboard. So the comma and period keys on the keyboard will enable you to go back and forth through frames. And that can sometimes be a faster way than trying to click on a frame, move the playback head. So I can just, with one hand on the keyboard, one hand with my drawing instrument, whether it's mouse or tablet, I can go through and fix things. Of course, now I have to fix where I erased a hole in the eye. So setting the frame rate in the property panel can be a useful way to better preview what you're doing. It gives you some indication. Now, one thing to keep in mind is we can set the frame rate to 60, animate at 60 frames a second, and then when we run our program, the program may start to choke and not be able to maintain 60 frames per second and may lower down. So what you're doing is you're getting kind of a ballpark feel for how it's going to be. It requires some more advanced activities when we're coding to try and get it where we can more precisely maintain, not only control, but maintain a consistent frame rate as a project plays. And that's beyond the scope of what we want to try and do right now. Right now we just want to create some frames of animation. And then we want to use these frames to create an image sequence. Our animation are done. The next thing that we need to do is we need to get this artwork into a movie clip symbol. Because when we do that, we then are able to export that movie clip as an image sequence. So to get these frames of artwork, not just the artwork of one frame on stage, but all of these frames, we need to highlight all of those frames in the timeline. And then if we right-click, you will see there's an option for copy frames. And that's what we choose. I suppose under the Edit pull-down menu, there is Edit Timeline. We can choose Copy Frames. So yeah, it's there too. But normally, you're working in the timeline. You're not working on pull-down menus when you're actually doing stuff. So I find right-clicking to be a better option. So you highlight the frames, right-click, and choose Copy Frames. Next step. So step 1, create your artwork across multiple frames. Step 2, highlight those frames, copy frames. Step 3, insert new symbol. We're going to create a movie clip. Give it whatever name you want, doesn't matter. No spaces in your name, please. You'll keep it simple. You'll understand why in the very near future. Then we hit OK. That now brings you, and you're like, whoa, everything disappeared, and that's OK, because we're now inside this symbol that we're creating. We click on its frame 1. So now this is going to be step 4. And then we go down and choose Paste Frames. And that put the frames in the artwork there. So step 1, create artwork. Step 2, copy frames. Step 3, create a new symbol, movie clip type. Because there's 3 kinds of symbols that we can create in Flash. And then step 4, right-click in the timeline of this brand new symbol we made and paste frames. 1, 2, 3, 4 steps. And then once we have completed that, we're going to look at our library, and we will see there it lives inside our library. After following step 1, 2, 3, 4, create your artwork, copy frames, create a new symbol, paste frames. Now we're inside looking at our library. I can right-click on the symbol in my library and see that I have this cool option called Export PNG Sequence, and that's what we're going to do. So I'm going to export my ping sequence. Comes up, and I can choose where I want to export that to so that I can work with that. Now, if we're going to be working with this, it needs to be in a data folder so that we can work with it inside of processing. I'm going to save my file. Don't do anything with the name. I'll just leave that, save it into a data folder, PNG sequence. And then when I click save, it brings up one more screen. Now, this is where we do want to pay attention. I noticed that apparently when I drew my artwork, I did get the full width, but I was a little bit short, 47 by 50 pixels. So we can leave that, just take note of it. 72 DPI, that's fine. Colors, 32-bit, that means it will have a transparent background. Yes, we want that. Final thing is to pay attention to how many frames it is. Mine is 35 frames. Yours will be how many frames you made. I don't care how many yours is, but you need to know the number. In my demo, I will be using 35 this afternoon. If you put in 35 and don't have 35 frames, you will get an error message. So make sure you pay attention to how many frames it's telling you were in your animation. Then I hit export, done. So 5 steps. Sprite animation file. It's got single sprite object. The sprite has update and display. So all those things that we used in the catcher game, we're recycling now. And then we have the sprite class. Now, a few things about this is the sprite class has more than just X, Y, width, and height it cares about. It needs to know how many frames it is. It needs to know what its current frame it should display is. And then it needs an array of images. That array of images is how we store those different images that make up this animation. And what we do is we populate our sprite with those. So the current version of this, which used my face animation, which is similar to the animation that we just saw. It's a different kind of blinking eyeball that I have here. It goes kind of fast. So now I'm going to switch to my other eyeball. Apparently I like that color scheme because I recycled it again today. But I was thinking blue for a blue planet. Then I needed, I like the bright green with the blue because it's an alien eye. But now it's got the red iris, so that'll be fun. So what we do is current frame starts at 0. Frames is 23. Well, it is. That one's 23. My other one is 35. My width is 47. My height was 50. Now I remember those numbers because when I was in Flash and I said create or generate image or PNG sequence, it told me how many frames and it told me my width and height. If you don't remember that, you can, no, not there. You can, well, no, not there. We'll get to it, we'll get to it. In that data folder, if you don't remember it, if I look at the Earth, if I go to that file, I can see my Earth, as I saved it out, is 47 by 50 pixels in size. And if I scroll down through the list, I will see I go all the way up to Earth 35. So that if I don't remember those numbers while I'm working in Flash, it's not the end of the world. We can always get to them by studying our files at the finer level. So that would be a way that we can get to that. So mine is 47 by 50. I have 35 frames. The name of my file is not face anymore, but it is Earth. So if I go where it says face and type in Earth. Now, if we look at this, we see a really weird, boy, this looks like a computer person must have written that line of code. And I would like to say that I was so smart I figured it all out on my own. But I was looking through a reference book on processing, and it had instructions on how to do loading an image as part of an image sequence using NF. Now, this NF function here, what it does is it stands for a number format. So if I say NF and I give it a number and then comma and a second number, the first number is the number that I want to appear. The second number is how many place values I want to assign to it. Going back to the Finder, if I look here, I will see that my images are Earth 0001, Earth 0002. So what this tells me is I could actually go all the way up to Earth 9999. It's 4 numbers long. If I look at my code, it's going to generate a value that is 4 numbers long. So I could say images 0 equals load image Earth 0001.png. Then I could, images 1 is equal to Earth 0002.png. This little line of code here allows me to format sequential numbers. My for loop I starts at 0. 0 plus 1 is 1. So it goes Earth 1 with 4 place values, so 0001, and then it adds in the .png. Next time through, Earth. I is now 1. 1 plus 1 is 2. So it'd be Earth 0002.png. And just keep going through the list until we're done. So we have to do the I plus 1 because our image sequence when it exported started out not at Earth 0000, but it started at 0001. And that's why we have the +1 here. 4 to represent those 4 numbers, 000, and then whatever number we're looking for. And as I gets bigger, it'd be 0010, 0011, because that 0011 is 4 numbers long. And it continues so on and so forth. Now, if our image sequence was only up to 9, I could actually say Earth 000 and then plus I plus PNG, because we, but when we need to have 01, 02, 03, 04, 05, 06, 09, 10, 11, 12, 13, 20. So because we need that variety, the number format NF command and processing saves the day. Otherwise, it's much more of a pain in the butt to try and write this kind of sequencing of numbers. Now that I've proven it works, we load all of our images. Notice loading of images must always be kind of in a constructor or a setup. And we will be, as our projects have lots of image sets that we load down the road, we will be controlling where we load those images, because in some projects all of our loading will take place at the main level, not inside a class. It depends. But for today's purposes, loading them in a class is going to just be, I think, easier code to work with. So that's what we're going to do. Then if I want to display the images, I say image, and I grab the whatever image is at the current frame in my images array, and then I just stick it on screen at X and Y. And then I make current frame go up by 1. And if current frame is now equal to my total number of frames, current frame goes back down to 0. Now, if you read the scary math chapter as you were asked, it did talk about the modulus math function, which we have talked about previously. And if you use that, you'll see there's a commented line of code here that does the same thing as these 4 lines of code. So for those of you who want like tidy, pretty code, instead of using 4 lines of code, I can comment that, and I can just grab this out. And that says current frame, which starts out at 0. 0 plus 1 divided by my total number of frames, 35. Well, 0 plus 1, that'd be 1. 1 divided by my total number of frames would be, that means 35. 35 goes into 1. 0 times remainder of 1. Okay, now it's 1. Now current 1 plus 1, that's 2, and becomes 2, goes all the way up. 35 divided by 35, that now is going to give me a result of 1, remainder of 0, keeping the 0 part, because modulus, the percent sign, keeps a remainder. And then we go on. 36 divided by 35, that'd be 1 with a remainder of 1. So what it does is it gives us this repeating sequence of 0 through 35, 0 through 35, 0 through 35. It just keeps going. That's how our modulus works. That's why we're able to use it to make our magic happen in this instance. So then I can see my blinky eyeball here. Now, if I want that eyeball to animate or move or something else, I could always just go x is equal to mouse x, y is equal to mouse y. Run it again, and we'll see that blinky eyeball now follows me around on the screen. If you get bored with it standing in one place, you can do that and work with it. Now, there's some other code down here which is bringing us into the matrix. And just pull that out. It's pretty much the same sort of thing, except instead of drawing our item at x and y, we draw it at 0, 0, because we translated to 0, 0. So we say push matrix, translate to x and y, and then draw at 0, 0. So the end result, if I run this, there's visually no difference. But if we are going to be using translate and matrix and rotate and all of that stuff, we do need to realize this is how we need to draw it. Now, if I want my object to be centered, so the animation is centered around its origin point, so it can rotate around its middle instead of from its top corner, then we need to adjust how we put it on screen. So instead of drawing it at 0, put it at half of its width and a negative half of its height. So that will, now if I run it, it's easier just to see it. And you can see now it shifted the display of the artwork over a little bit. So now it's centered on the mouse. Because ellipses draw from their middle. Rectangles draw from their corner. The sample files on the solar system used rectangles to draw from their corners. Because when we use images, images draw from their corners because images are rectangles. So that's why we do it that way. So now if we can do an image with this, we can now stick it into our solar system and see all kinds of fun stuff start to happen. So in the solar file, which has a bunch of boxes rotating around a box, right now these are my stand-ins for my planets that I'm going to work on, my animated planets and moons. So we have animated moons, animated planets, moving around a sun. The sun is just another planet, because there's no reason for it not to be. So if you go through the chapter on matrices and translate and rotate and all of that, there are some basic instructions on putting together a solar system. But what it does is it just uses a for loop and just creates a set of 8 planets and just puts it on. It's like, okay, that's fine, but if I'm just going to dump 8 planets in, I don't have a lot of control about how I want each planet to be. And if I want to think about trying to create if I wanted to recreate our solar system somewhat proportionally, so big planets were big, little planets were little, and which one was in which orbit, then I would have to do it individually. And that's how I set this starting file up, where your homework is going to be to integrate this with images. So you are going to modify the planet class and the moon classes to use animated images for each one of the orbiting bodies. And I would hope that you add in more planets than just the 2 that are there. Now to do this, we're going to take a look at the planet class and the moon class and try to understand a little bit about how that is coming together. And you can see they've left some old code in which talks about there was a sun that was just a fixed ellipse from back in the previous planet, or the planets example, without classes. But now using classes, we're doing it. So push matrix, translate, same as before. Then we cycle through the planets and update and display each of the planets, pop matrix. So that's what the main thing does. Currently I have 3 planets, and each planet is receiving some information. Now, the planet class, we can see there's a planet class and there's a moon class. The moon class is very much like the planet class, except the moon class doesn't have any moon information in it. The planet class needs to know how many moons it has, because if it has moons, then the moons are being generated randomly, trying to keep this from getting like too complex. So it just gets a random number of moons, but then you can just create a moon animation. So for your moons, just there's one moon animation. You don't need multiple moon animations. You can certainly add to the coding and put it in if you want. But the planet class, when you create a planet, you specify what is its diameter, what is its distance from the sun, how fast is it going, and how many moons does it have. So when we create a planet and say, I want a new planet, We provide information. We say, how big are you? Where are you? How fast are you moving? How many moons do you have? And to see how nicely this works, so we can see here's the sun. The sun is 50 pixels across. And the sun is at 0. Its distance from the center of the universe is 0. Or solar system, not universe. Its speed is 0. It's not moving. And it has no moons. The next planet has a diameter of 20, distance of 100, speed of 1, and no moons. Now, if we remember seeing this, that's what it looks like. Sun, first planet, second planet has 3 moons, second planet is bigger than the first planet. Now if I modify this and say, okay, well I want the first planet to have a moon. Okay, I'll add a 1 there. Now hit go, and now they both have moons. So we just modify the parameter and we're able to pass in that information. So what's going to be changing on the planet class is it's going to be changing its display. So instead of drawing a rectangle filled with the color red, it's going to be showing an image. Using an image. Translate's done, rotate's done, matrix is done. All of that, jump into the matrix stuff is done. What we have to do is now integrate images into that. So we can integrate it in. We need to load images in. We're going to need a current frame value. We're going to need a images array. We're going to have to load images in for each planet. So to blend these together, or to meld these two files, one thing that does need to happen is I need to work on getting my data, my different files, into that project. So if I look at my solar project, I can see there is no data folder. So I'm just going to be super lazy and put a copy of my data folder from my sprite animation into my solar folder. So now it has access to all of those data files. Heck, now I can animate 3 things. Sweet. I even, maybe I'll go grab, and we'll just leave that for now. All right. And get my file up here. So now looking at the solar file, we'll see that there's a few things we'll need to do. We'll need a couple extra variables. If you have your sprite animation file and then the solar file open side by side, we can just copy paste between them versus retyping, or you can retype. It's not the end of the world. But our planet class is going to need a few extra variables now to make things work. So for our planet class to work, it's going to need a frames value, a current frame value, both integers, and then it will need an images array. So we will need those additional variables as part of our planet class now. Because if we have those, then we can start working with it. And once we've got those pieces in, we need to then assign values to them. Current frame always starts at 0. Our number of frames will be equal to, and now this is where it's going to get interesting. What we can do initially is hard code the value in, and then we will learn that if we have multiple planets, each one with its own set of images, we're going to have to pass that information to the planet class so it knows how many frames, it knows what file to use. So we'll work on that, but first let's get it going. And this is how to approach the coding, is to always do a little bit, prove it works, and then worry about how to get fancy. If you get fancy first, it never works. It doesn't work, and all it does is make a person grumpy. Now this is where we're going to use the whole for loop and load our images. So I could copy paste that or just retype it. If your typing sucks or is slow, I would encourage you to just copy paste. If your typing is fast, go nuts with doing it yourself. That's fine. So we're using load image, and then we concatenate the string of Earth plus a bunch of numbers plus .png. And that's our fancy vocabulary word for the day of concatenate these different elements to create a compound string. Line I forgot, our images, before I can populate it, I need to make it into something equals a new p image, and its length is my amount of frames. So I've now grabbed the population code from the sprite class, put it into my solar class. Then I'll need a few lines from the update method in my image class, or sprite class, that I will be putting into my planet class. And for that, it's just 2 lines of code that we'll have to modify a little bit, but at least it gives us a starting point. So we're just going to grab 2 lines of code and move them over. So instead of grabbing a fill color of red and drawing a rectangle, because rectangles are boring, in this case it's exceptionally boring because it was just a boring square. So now I'm going to just bring over where I use my image command, and then I say show me the image in my array from the current value, and then we're going to offset it so it gets centered. Now in this case, we don't have a W and we don't have an H because our planets before were circles or ellipses. So if we want, we can modify the planet class to accept a W and an H value and then set those, or assume that our artwork is close enough to square that if I de-squarify it here, nobody's going to cry. So I'm just going to grab a negative diameter value divided by 2, which is similar to what we saw in the, on the rectangle. Actually, it's the same as what's on the rectangle, not even similar. So now that draws the image at that point. Now, the image method, which says draw this image file at this location, has 2 more parameters we haven't used yet, which are how big we want it to be. So we can actually make it, we can specify a width and a height here. Because if we remember previously when it created the planets, it was passing in different diameter values, which are essentially widths and heights, or well, used for width and height. So if we were to do that, saying we specify the image file, we specify a location, 2 more parameters we can put on are a size that we want it to be. So I could say diameter, comma, diameter, like that. I can do it that way, or, you know, in this case I could put in 4750 because I know that's what they are. But if I do it with diameter, then it's going to scale my image up or down, which is kind of cool. So that when it draws it, it will be scaled based on this value. So to see in action, see it in action. All right. So we've got everything going but the animation right now. So the images are showing up, but what we don't have is the line that then says update current frame. So the current frame is equal to current frame plus 1 modulus frames. Or if you want, if current frame is equal to frames, current frame is reset back to 0. So if you want to do it with 4 lines of code this way because the modulus math scares you, totally cool with that. Or you can use the single line of code as it looks down here. I really don't care. It doesn't, I mean, it's whatever you want. It makes no difference to me on that one. So I'm going with the single line just so I take up less screen real estate. And now if I'm just going to put a line in here, the comment, moon stuff. And now we can see that they are blinking. Notice they're all blinking in unison because they're all coming from the same animation. Now one thing is if you put a bunch of the same animations on screen and you don't want them to all start with the same frame so they appear to be unique instances, there's a way to do it. Now, as the project comes up, it gives me my eyeballs all moving around. When they are not the same artwork, it doesn't matter that they're all blinking in unison. So if I want to replace these so that they are a little bit different, what we need to do is modify this so that when I create a new planet, I am passing to it how many frames it has, and I am passing to it the file name. So I need to pass those 2 values in. So if I were to say pass in a value of, this is my sun, so I'm going to call this face because I have a face value. And I know that the face value, actually I don't remember how many frames face is. So let's see, blob is 9. I'll want to remember that. Face is 23. Okay. So now I pass in a value of 23. Now for my Earth, pass in a value of Earth, and Earth was 35. And for my next planet, I will let this be blob, and I will pass in a value of 9. Now if I know the sizes of those, so that if I look at face, face is 32, and blob is approximately, I'll just say 40. So face is 32, blob is 40. Okay. So now I've passed in those values. So if I were to run this right now, it's already telling me it's unhappy because my planet constructor line is not prepared to accept a string or one more number yet. So we need to update that. And that would be in the planet class. So if I look at the planet class is using these things. We just need to now do something with it. So right here, we're passing in a string, if I could spell it right. I'll just call this file path. And actually, it's file name, because we construct the path. So it's my file name, and then I pass in an integer, which is my number of frames, and I'll just leave that as fr. So frames is now equal to fr. And instead of the word Earth here, I pass in my file name. So this now means whenever I use the planet class, I can pass in whatever file I want to make this happen. If we run it over here, we'll see that I now have my 3 separate animations showing up on screen.